Hello everybody, welcome to my YouTube channel. Today we are going to solve magnetic force between two balls. In this problem, our goal is to place M balls in M positions to maximize the minimum magnetic force between any two balls. The magnetic force between two balls is calculated by X minus Y, where X and Y are the positions of two balls. This means the magnetic force is the gap between the two balls, respectively. So it's a positive number. In example 1, we have used ball 1 in the basket 1 in position 1 and in position 4. So we can see the magnetic force is 3. But if you place the two ball between 4 and 7, still it's 4. So the maximum value here will be 3 in any configuration. If you consider the possible configuration, you'll see that it will be 3. So in that case, the answer will be 3. But in the second example also, we can see if we use the configuration and calculate the gap between any two given balls, you will see the value will be 1 at position 1 and at this position, so it will be 1 this value minus 1. So 10 to the power 9 minus 1. So it is 9999. A lot of 9s there. Now let's dive into the explanation here. So the brute force way will be just to run over everything and try all the possible configurations or the possible cases and then come up with the maximum minimum magnetic force. So in this figure is for explaining how the gap is calculated. So if you place the ball at position 1, this is position 2, and this is position 3. We can see the ball 1, the gap between the force between ball 1 and ball 2 is 2 minus 1, so it's 1. But in case of ball 2, which is this value, and ball 3, which is this value, the difference will be 5, 2 minus 7. But if you take ball 1 and ball 3, so it will be 7 minus 1, so it is 6. So same thing goes here. So there is, if you think about it, we can come up with an algorithm. We start with the maximum possible value of X, and then we attempt to place all the balls with the at least this gap of X in any two successive one. So for example, the initial value of X may be 1. So then we can place the balls with gap at least 1. If not possible, we stop. If yes possible, then we start. We continue, we increment X with 1, and then so on. So up to when it's no longer possible, so that will be our answer. This method can be further optimized. We can try a given gap X. Two outcomes are possible. Either we successfully place all the balls with at least a gap of X between them, or we can place them. So in the first case, it's here. See, the gap is 3, and we can place the gap 3 between all of them. So we can see in this case, the ball 1 is at this position, ball 2 is at this position. The gap is 3, so it is 4 minus 1, which is 3. The same thing goes here. 7 minus 4, so it is 3. So in that case, we can place all of the balls having at least a gap of X. Same thing goes here. You can see in case of 2 and 1. But if you take this example, this is the second case. In this case, it's not possible. we can place all the balls having at least a gap of 4. And let's say in this case it is 4, but we can see we cannot place it here. So same thing goes here for this configuration. So to solve this problem, you have to use binary search. So the algorithm goes as follows. We create a helper function that will tell us if it's possible to place the gap or not of at least x. If it is possible, we return true. We initialize previous ball to the first position. So in this case, we have to solve the positions. I mean, the array will be given, so we have to sort them from smallest to greatest. So initially, you have the smallest the previous ball position will be the smallest, and the ball plus count will always be 1 for the initially. Then we increment it every time when when you can place all the gap. So we'll increment it by 1 as you have seen it before. So after doing this, we iterate over all the position from index 0 into index of position size minus 1. And if we place all of the m balls, so that means we can update the previous ball to position I, increment the ball place by 1. So then you return the ball place if it's equal to m. So our goal is to have the ball place equal to m. So the gap should be at least m. So the initial value for answer will be 0, denoting the minimum magnetic force, and the m positions is the array size. So we showed the array, have I said before. So in binary search, we have two index, or 3 in fact: low, high, and mid. Mid is high minus low divided by 2. As you can see, the calculation is done here. In this case, we are avoiding overflow. So if we can place all the balls at a gap of mid, then we update the answer to be mid. So that's our answer. Then we'll try again. So we'll update left, then left will be mid plus 1. So we'll then try discard all the left part. So meaning from mid to the answer possible will be from mid to high. So otherwise, if it is not possible, we just shrink it. So to the right will be mid minus 1. So based on that algorithm, let's see now how to code it.